Today, we are going to talk about a proposed banking KYC utility which intends to improve customer onboarding and ongoing monitoring. Here, our team members are Ding Ruiqi, Li Kunrong, Li Siqi, Wu Xinyi, and I am Zhu Yi. We are going to cover these parts today, including the workflow and the wireframe for KYC utility and some design considerations. First, let's take a look at the customer onboarding part in our KYC utility workflow. When a corporate client approaches Bank A for the first time, he will be requested to upload a one-time setup of golden source of ACRA and MyInfo. For foreign clients, request a business registration document from national authorized entity. Then bank will forward to KYC utility for verification and due diligence database. We first assume that the client don't have data stored in KYC utility before. Then the client's document need to be verified first. For foreign client, we assume their document information should be similar to ACRA and can be transformed to ACRA format by machine learning. If the document client provided is not valid for due diligence use, then the KYC utility will notify the bank for further requests. Once the documents are verified, KYC utility will top up on the internal source by gathering information from public and premium data sources trusted by regulators. After data aggregation, KYC utility will process unwrapping of UBOs through extract data from the data source to establish ownership and control structures, including UBOs, visualizes these structures as a diagram and provide showing entities of interest and how they relate. After the unwrapping of UBO, the KYC utility will produce a comprehensive KYC profile of clients complete with source documents and due diligence data attributes lineage. Then we assume that in the upcoming CDD progress, through name screening and risk rate in a KYC utility, we can directly apply existing technology of screening engine tools and automated risk engine. So these two steps aims to inform risk scoring and provides the data baseline for bank due diligence reference. And then we return the KYC dataset and the initial risk rate result to bank. Bank may verify the result by performing internal compliance or risk assessment process to decide if the KYC process of the customer is failed or not. If failed, reject the client onboarding. If not failed, risk rate the customer by bank and MAS policy to define if the customer is high risk or not. And then the bank return their operational result to the KYC utility. KYC utility will update and amend the result in the KYC profile. In this case, for the same banking group, they can refer to the CDD result to reduce its effort spent in repetitive due diligence processes. Same process to update or amend the KYC profile if have any data changes in the ongoing monitoring parts. For every time the document have changed or updates, the KYC will hash the updated documents using the hash function. The hash of each verified document will then be stored on the unique ID of the customer created on the blockchain. This is important to note that the hash will not contain the contents of the KYC data. It only represents the code name of a specific file. This will be done to prevent the customer's sensitive information from being accessed by other members on the blockchain network. Now, if the customer already have KYC data, this could be the data from other financial institutions. If the data have no any changes, bank can getting access to the client profile by extract the unique ID of the customer present on the blockchain platform, and goes through the CDD process with bank. After verification, update and store the finalized risk assessment result. If there's differences on the database and then stored in the distributed ledger in blockchain as the same process to share with other financial institutions.
Let's move to the second part of the KYC utility workflow, ongoing monitoring. In this part, we will consider two deliverables. The first will be how we manage the periodical refresh cycle. For the high-risk customers, annual refresh will be applied by KYC utility to align with bank's requirements. For medium-risk customers, 2-year refresh cycle by KYC utility for consistency and efficiency. As for the low-risk customers, 3-year refresh cycle by KYC utility to match bank's cycle. Here, as for the additional considerations, ongoing monitoring and event-driven triggers for refreshes when customer info changes or adverse media occurs, or watch list or risk factor updates, or changes impacting risk profile. The next deliverable will be how we manage intraday bank requests. Here we will establish 3 systems. First will be establish a centralized request management system, and second is implement request duplication and conflict resolution. And the next will be implement access control and audit trails. Now let's see the details of the ongoing monitoring system. In this part, for the transaction monitoring, when 3 trigger events are triggered, we will start the next part of the risk assessment. There will be periodical name screening, ongoing refresh, and then dynamic risk assessment. In these 3 parts, we have some technologies applied here. For the screening, we will use screening engine tools and screening input optimization. As for the risk assessment, in the initial risk rating, we will use the automated risk engine. And for the final risk rating, we will apply the automated collaborations. After the suspicious transactions are detected, we will start the reporting procedure. Here we have 4 steps. The first will be exception reporting and then escalation management, then move to the regulatory reporting, then the continuous improvement. In these 4 parts, we have technologies applied here are 4I review and here we use a workflow that is create and cause a task for quality control review and the quality control. In the approval part, we will also use the workflow to create and cause a task for management approval. Yeah. And that is the ongoing monitoring system.
Next, let's compare how many handoff points between bank and utility and between customer and utility. First is the 4 handoff points between bank and utility. The bank first needs to transfer the initial KYC process to the utility, including obtaining and verifying KYC, unwrapping UBO, and conducting the name screening part. Besides, the bank also needs to transfer some specific requirements or documents to our utility for EDD. And the second point requires the utility to return the result of the initial KYC checks, UBO identification, and name screening back to the bank. And the last 2 are both about updates. Banks should monitor the results that need record updates or affect the risk bands, and utility should update on the mutualized data relevant to the bank's customers. Above are the 4 handoff points between bank and the utility. In addition, we also take some possible continuous and less discrete handoff into consideration, because ongoing monitoring may require a continuous exchange, with the bank monitoring transactions and the utility updating records and risk bands. This interaction is more of an ongoing dialogue rather than discrete hand-off point. Therefore, we did not include this section into the counting part, and it is only mentioned here for your reference and information.
Then I want to talk about the hands-off point between the customer and the utility. There is no hands-off point between customer and utility, but has one point between customer and bank. Initially, the customer provides information to the bank, not utility. The information includes identification documents, proof of address, contact details, etc. So the bank can record and verify the customer's identity and then update the information to the utility.
And the sixth part is about the key dependencies for the successful launch, which is summarized as these 6 points. The first one is regulatory compliance. The regulatory approval helps ensure that the utility complies with all relevant KYC and AML. Besides, it provides adherence to something like GDPR in the EU, CCPA in California, and also some other relevant data protection and privacy regulations in the jurisdictions that the utility operates. The second one is technological infrastructure. Robust systems are required to handle large volumes of sensitive data with scalability to accommodate growth, and they must be compatible with the diverse IT environment of participating banks and financial institutions. The third one is stakeholder alignment. One of the utility's key value propositions is to obtain a commitment from banks and financial institutions to participate and share data. From the perspective of customers, the utility should clear the mechanisms for obtaining and managing customer consent for data sharing and processing, respecting their privacy and control over their data. The fourth one is effectiveness and efficiency. To ensure smooth operations in the process for CDD, comprehensive support and training programs are required for staff both from the utility and the participating institutions. Additionally, there is also a strong need for mechanisms that help ensure the accuracy and timeliness of data processed. The fifth one is collaboration and partnership. The utility not only needs to build partnerships with some tech-related companies for AI, ML, and blockchain technologies, but also needs to collaborate with some industry bodies to ensure alignment with broader financial sector goals and practices. And the last one is financial viability. Basically, the utility needs to secure both the initial and the ongoing investment. Furthermore, a clear business model is also highly recommended to ensure the utility's operations to be financially sustainable while delivering value to participating institutions.
Then I want to talk about the co-design principles and considerations. By considering the following principles, we can ensure that the KYC process operates efficiently, safely, and reliably. First is privacy protection. The customer personal information should be strictly protected and can only be used for KYC purposes and in compliance with relevant privacy regulations and policies. Utilities should use encryption technology to protect the security of data during transmission and storage, and implement access control and right management to ensure that only authorized personnel can access customer information. The second is data accuracy. To ensure the accuracy and completeness of customer information of effective KYC verification, we have to regularly update the customer information and ensure consistency and timeliness of information. Implement data quality control measures to identify and correct data errors or inconsistencies. The third is automation. We use technical means such as AI and machine learning to automate the KYC process, include data collection, verification, and analysis. Ability to automatically identify abnormal or suspicious customer behavior and conduct real-time risk assessments. The fourth one is scalability. We use flexible architecture and technology to design systems to support a growing customer base and data volumes, with the ability to quickly expand and adjust customer capacity and performance to meet future needs. In addition to this, develop sustainable expansion plans taking into account future business growth and technological developments. The last is interoperability. We design systems to ensure seamless integration of system and data sources across different financial institutions. And we support standard data exchange protocols and interfaces. And the needs of circumstances of different financial institutions vary. We need to ensure that the system is flexible and adaptable.
Okay, let's dive into the wireframe to see how it works. First up, we have the main page displaying all current customer information. You can easily access the real-time updated customer list by pulling down and use the Upload button as the button to import information obtained from corporate clients. When you click and select to import information, you will be taken to the second screen. Here you will see the system processing the information with a process bar showing a processing status and a list of specific customers being processed below. Once the progress bar reaches 100%, indicating successful information processing, you will return to the customer list page. This updated customer list combines new and existing customer information. Specifically, the page first shows customers whose documents did not pass verification, marked with a warning icon to alert the bank to document issues. Following that, you will see the updated customer list, including existing customers with updated information and new customers. In the customer list view, clicking on the ID number of each customer will take you to the fourth screen, which is a detailed KYC profile for each customer. Here you can access specific KYC information, including risk assessment, risk scoring, UBO information, name screening results, transaction monitoring results, and related proof documents. Additionally, there will be warning icons indicating where the customer poses risks or issues. Moreover, this profile details will be automatically updated as changes occur to existing customer information in the system, enabling continuous monitoring and ensuring up-to-date records. This wraps up our wireframe design. We aim to provide a user-friendly experience with a clean and consistent interface, making it easy for users to navigate. We've also structured the design logically to enhance usability. Furthermore, we aim to provide timely feedback to users, such as using a progress bar to indicate the current status. This concludes our presentation of the proposed banking KYC utility. Thank you for your listening.